Today we will talk about how to load a lot of data to MonetDB. I will first start MonetDB and then I will log in to BSC database. But this time I will use this switch timer is equal to clock. This means that during this session, after each query execution, we will see how much time was used for that execution. I will type my password BSC. And then I will create one sample table. This is a simple sample table with only 3 columns. Now this table has some constraints. It has unique constraint, primary key constraint, and not null constraint. I will now run this. And here we can see how much time was needed in order to create this table. If we use this switch, then after each query, we will see this timing. Next, we will insert some data into our table. I will insert only 3 rows. And at the end, we can read from our table to see how it looks like. So this is our table. Now, if we want to insert just a few rows, then we can successfully use insert into. But if we want to insert a lot of rows by using SQL, we will still use insert into, but if that number is really big, for example, 1,000,000 rows, this will be really slow. Now, we know that we can use insert into to insert several rows at once. For example, here we can see that I'm inserting 20 rows, but we cannot use one insert into statement to insert 1,000,000 rows because then everything will be really slow. So we have to use a lot of individual insert into statements, but we can speed up this load by following some advices. And those advices are here. We have 5 advices. First, we should disable auto commit. That means that we should wrap our load into transaction. Then we should prepare our statement. So we will create only one statement. We will parse it and cache it. And after that, we will always consecutively call the same statement, but we will use it just with another parameters. Then we should use batch processing. That means that instead of using 1,000,000 insert statements, we will use only 10,000 insert statements, but we will have 100 of such batches. So we will do inserts group by group, and this will reduce communication latency between application and Monet. Application is the code that is actually using this insert into to insert some data into Monet. This will reduce memory usage, and it will also minimize locking of a table. Because this insert into statement is really simple, it cannot be more optimized, so we will also disable optimizer. And finally, we saw that on our table we have some constraints like primary key, unique, and not null, and we will temporarily disable these constraints, and we will turn them on again after we load our data. Well, I'll go back to terminal and I will clean my screen. Now I will insert one row into our table, and we will notice how much time do we need for this insertion. After this, I will try those tips. I will first disable optimizer, and then I will disable constraints on our columns. And for that, I will first find out the names of our constraints. So I will read from system tables. So these are our constraints. I will first remove constraint for unique, and then I will remove constraint for primary key. And we will not remove not null constraint because not null constraint doesn't really affect performance. Now I will start a new transaction, and then I will prepare my statement. And now we are ready to execute our statement. We can see that ID of our prepared statement is 0. So we will execute that prepared statement with that ID. And we can notice that we are now much faster. At the end, I will change everything back. So I will first commit this transaction. Then I will delete my prepared statement. then I will turn on optimizer again, and I will also turn on my constraint. First unique constraint, and then primary key constraint. And this is how we can speed up insertion of data. I will now clear my screen. Now I will execute the same experiment again, but this time from Python. In one of the previous blog posts and videos, I have shown you how to connect to Monet from Python. And just like then, I will be using Spider. So we are going to Spider. Here I will paste Python script. This is a simple Python script. So I will first create a connection. Then I will execute 10 insert into statements. I will calculate the full time for execution and I will print that time. So I will now run this, and this is my execution time. I will then delete this script and I will use other script. This other script is improved, and it is improved because it is following all of those suggestions. So we will first change optimizer, we will drop constraint, and so on. So I will now run this script. I will run it, and we can see that this script is faster. I will now go back to terminal, and we can read from our table to see all of the rows that we have inserted. So this time we have inserted 20 rows, and this is now our table. I will now clean my screen. I will now quit this session because I want to show you one more way how we can measure our timing. This time I will log into my database, but I will use the timer is equal to performance. So I will use this other mode. I will run this. I will type my password PSC, and then I will shrink my table. I will delete some rows because I don't need all of those rows. And now instead of getting only one value, I got 4 values. First we have SQL. This is the time needed for parsing this statement. Opt is for optimization of this statement, and this is the time needed to run this statement. And at the end we have again our clock, so this is a total time. I will now clean my screen. We saw how we can observe timing of the current query. But what about query history? What about previous queries? What if we want to see query execution timings of the previous queries? Well, we can see those timings in 2 tables, and we can access those 2 tables by using these 2 functions. But in order to use these 2 functions, we have to log in as administrators. So I will quit this session, and then I will log in as an administrator. My password is MonetDB. And first, I will empty these 2 tables, because these 2 tables are permanent. So their content is persistent between sessions. So there can be some content inside of them now. So I will first empty them, and I can do that by calling this procedure. We are calling procedure by using call keyword. So I will run this, and now our tables are empty. And next I will start logging of timings. So for that I will call this other procedure. Because sys is current schema for administrators, I don't have to use a sys prefix, so I will just type the name of a procedure. I will run this, and now we are logging our timings. Next, I will execute some statements. So I will execute this statement here, and I will execute it 3 times. And now we can read from our first table. I will read from table query log catalog. So I will run this query, and here we can see who ran this query. So the owner is the person who ran the query, and we can see the timing when the query started. We can see it here. We can also read from that other table query log calls, and here we can see when our query started and when it ended. At the end, if we want to stop logging of timings, then we have to call this procedure, query log disable. If we run this, then we will not further register timings of our queries inside of these tables. Now, the number of these results inside of these tables can be really big, so we can have a lot of rows, and it would be troublesome to find a timing for some specific query. In order to achieve that easier, we can use an argument for query log enable function. That argument is time in milliseconds. So if we run a procedure like this one, in this case we will not log every query, but only those queries where time execution is longer than 5 seconds. So this is how we can limit the queries that are registered inside of these two tables.